Welcome to Authentication and IAM. Daml applications cross organizational trust boundaries, so authentication is a cross-cutting concern that requires attention in your solution architecture. In this lesson, you will learn how to select a suitable party topology to manage authentication both of end users and back-end services, including the specific considerations required when providing back-end services to external entities across trust boundaries. We have seen in previous courses how Daml applications are built around shared consensus, and that Daml allows consensus to be achieved over trust boundaries. It is the Daml ledger managed across participant nodes sharing a synchronizer that provides this consensus. Daml parties provide first-class global identities that act on and share in the ledger consensus. In Daml applications, they are used to represent the organizations interacting with each other in a synchronized manner over the ledger. Obtaining the ability to act as a party is to obtain the ability to act as the organization. Obtaining the ability to read as a party is to obtain the ability to observe every contract or ledger event visible to the organization or organizational entity that party represents. As a result, your Daml party topology, deciding the granularity of what organizational entity a party represents within your application, is a critical design concern. It is critical that each organization appropriately controls the access to the parties that represent the organization. This is typically achieved using authentication credentials issued by an IAM system under their control. Without that control, an organization would lose control over the workflows run on ledger with their counterparties, and whoever had access to act on the ledger using an organization's parties could advance that organization's workflows for their own benefit, which is why the Daml application architecture is the way it is. The benefits provided by Daml and Canton that we discussed in the earlier courses rely on this provenance chain of trust, the ledger authorization, and its association with organizations' Daml parties. The credentialing of participant users access Daml parties hosted on participant nodes. And in operation, the management of access to participant users through an authentication process with an IAM under the organization's control. Delegating authentication across a trust boundary should be avoided as it weakens the authorization, delegation, privacy, and non-repudiation guarantees provided by Canton and the Daml ledger. The rest of this lesson will go into more detail about how to design your Daml party topology and how to manage the authentication of users and services within a Daml application. Those details matter, but the most important architectural takeaway is: in order for Daml to provide non-repudiation, each organization should control their own participant node and the IAM that controls access to it. In previous lessons, we have seen how Daml's privacy and authorization model is defined in terms of parties. Parties are the sole representation of identity on the ledger, and therefore signatories, controllers, observers, witnesses, and informees are all defined as sets of Daml parties. Consequently, Daml parties are used to govern access control to ledger data and therefore encode identity across interorganizational boundaries. For this reason, which entities will be represented as Daml parties in your application is a very important architectural decision. There is no single answer to this question. Your decision is going to depend both on your business case and the way you implement the business workflows using Daml. A good starting point is to use one party for the app provider and exactly one for each of the app users. It is not uncommon for this to correspond to one party per legal entity, and consequently one party per trust boundary. As a good default, each of these parties is allocated on the respective organization's participant node and represents that organization in on-ledger workflows. Note that more advanced party topologies, like hosting parties on multiple participant nodes or controlling parties independently of the participant node, are possible. The Canton User Manual has details, and Digital Asset can advise if or how these more advanced topologies apply to your specific circumstances. However, one party per organization hosted on their own participant node is a good default. For most applications, this will align party topology with the desired granularity of on-ledger visibility and authorization, where the relationship of app user to organization to legal entity are not one-to-one. You may need to consider if counterparties care about which legal entity acted in a particular workflow, or which of other options best represents the level of access control desired. Keep in mind that within a single trust boundary, you will usually have other options to manage access and authorization. So while more fine-grained party topologies are possible, they often leak entities' internal details onto the ledger and to counterparties. Note that data for all parties on the same participant node is physically consolidated. Interparty privacy is restricted to what is returned by the ledger API and in the ledger consensus between participant nodes. We instead recommend implementing internal access control policies via backend services, as explained in previous lessons. A single party per trust boundary is generally preferred. Where you do decide to use multiple parties for a single organization, try to align parties with stable business roles. As parties form the foundation of the ledger consensus, restructuring your party topology can be delicate and disruptive. Judicious addition of parties can help resolve business requirements. However, the point where party topology reflects internal hierarchies is an anti-pattern, as the party is the level at which ledger consensus and disclosure is defined. So make careful note of the witnesses of sub-transactions to ensure you do not inadvertently divulge internal details. Finally, keep in mind that adding unnecessary parties can lead to hitting scalability limits, which we will discuss further in a future course. Once you have decided on your party topology, it becomes necessary to consider how you will manage authenticating access to the parties by end users and backend services on the relevant participant node. In the case of backend services access to their respective participant node, the recommended approach is for the backend's administrator to allocate a service account for the backend in their organization's IAM. Then for them to create a participant user with the same name in the participant node. Identify the parties being mediated by the backend in the participant node. Note that while the example here shows two parties being used to represent the bank, this will often be only a single party. And allocate to the participant user read as and act as rights for each of the mediated parties. Finally, configure the backend to use the service account's user ID, OAuth client ID, and OAuth secret, and use those credentials when acquiring the JOT token required to access the Ledger API. A few points to keep in mind. The Daml platform is designed to allow the use of standard tooling and OAuth technologies, all the usual best practices that apply to allocating and managing service accounts apply. The relationship between participant users and ledger parties is not one-to-one. You can have multiple ledger parties associated with a single participant user. Multiple users can be granted access to the same ledger party. Each grant of a ledger party to a participant user can provide independent read as and act as capabilities for that user to that party. We recommend that front ends submit all their commands via a backend service and have the backend authenticate them as explained later. However, if a front end does submit commands directly to the Ledger API on a participant node, you will also need to allow front-end users to authenticate to the participant node. Generally, this will require creating participant users for every end user in your IAM with access to the front end. As with the backend service participant user, These front-end participant users will need to be granted read as and act as rights for the ledger parties accessed via the front end. Where the front end is talking directly to the ledger API, front-end users are directly associated with participant users. Consequently, this form of Daml application architecture is only suitable where it is appropriate for end users to be granted full authority to view and act as a specific party on the ledger, and where the party must provide the desired granularity of authorization and privacy. Common examples of this include applications where every end user is an entity within your party topology and therefore acts using a party of their own. Applications where end users are trusted by and acting in the name of the organization represented by the party, such as administrative, operational, and support front ends accessible only by trusted administrators and operations personnel. Given the larger number of participant users involved in direct front-end access, you will need to consider how you will create and configure them. While they can be set up manually using the Canton console, you may need to consider scripting the process. Use the primary party field to associate an end user's party to its participant user. If a user has act as rights for multiple parties, store the mapping between the parties and their respective purposes in the user metadata. Use the user endpoint on the Ledger API to retrieve the primary party and user metadata of the authenticated user from the front end. Often, it is technically simpler for Ledger access to be mediated by a backend API. When providing mediating backend services within the same authentication domain, use best practices and your organization's existing advice and facilities for authenticating the requests to your backend. Most applications should ensure all read and write access is mediated via backend, as this allows the backend to implement fine-grained access control at the service level. It then becomes the backend service's responsibility to authenticate the mediated end users and apply the required access control policies for the end user. Things are slightly more complicated when a backend needs to provide services to requests from outside the authentication domain. Otherwise, one option is to create service accounts within the app provider's IAM for external backends. A common use case for this approach is to provide read-only access to query reference data. When this option is available, keep in mind that the concept of inter-organizational identity on the ledger remains the ledger party. So, while the identity of the app user can be authenticated using the service account, you will also need to maintain an authorized mapping between that account and the app user's ledger party. This mapping can be stored anywhere durable, but a reasonable default is on the app install contract as part of onboarding, if there is no compelling reason to store it elsewhere. When the backend is accessed directly from end-user front ends in external organizations, this may require a more complex solution. If the number of end users is small, then it may be okay to create IAM users for them in the app provider's IAM in the same manner as with external service users, and use these to authenticate them. Using an IAM outside the application user's control has the trust implications we have already discussed, so be careful and explicit about what parties and permissions you map these users onto. Where trust issues are intractable, or for large numbers of end users, using a federated identity integration like SAML is advisable. With authentication and identity being foundational to Daml applications, it is critical that workflow tests include authentication. To that end, it is important to run your tests with authentication turned on. Mock authentication servers, or self-issued JOT tokens, created on demand by the test harness, can make it easy to set up the required access tokens for test runs. What is important is that your tests include concepts of identity and authentication to avoid surprises in production. Parties represent identity on the ledger. They are at the core of how the Daml platform provides authorization, privacy, and control over trust boundaries. The decision of how to allocate parties in a Daml application is therefore of critical importance. As a TSA, you need to decide for your business domain which type of business entity parties will represent. It is common for this to result in a single party per independent business entity. Occasionally, other stable business roles may be appropriate, but basing party topology on an internal organizational structure is almost always an anti-pattern. Parties are hosted on participant nodes. And to strengthen the chain of trust, every organization should have at least one party under its control. Access capabilities to parties are allocated to participant users, which makes the issuing of authentication credentials by each participant's IAM the provenance root of all trust in the system. The recommended Daml application architecture reflects this. Each organization hosts their own participant node. Participant user credentials are managed by each organization's local IAM system. End-user and off-ledger system access is mediated by backend services applying internal access and control policies. Finally, because authentication is so central to the guarantees of the Daml application, authentication should be included in your end-to-end integration tests from the outset.